Rajeeva Karandikar, and he's the director of Chennai Mathematical Institute, and it's for more than a decade now that he's handling, that institute, and it's real pleasure to have him here. And of course, he is very closely associated with Kerala School of Mathematics also. We have the integrated MSc PhD students here. All of them are here. And Professor Rajeeva Karandikar has played a pivotal role. In fact, from the beginning, and CMI, Chennai Mathematical Institute, has helped us from the very big inception to till the end to really see everything goes through. We are really thankful, Professor Rajeeva, that you are with us all the time. And so let me tell a little bit about Professor Rajeeva Karandikar, whatever I know a little bit. He's a statistician, and he's also a shephologist. And in fact, you'll be surprised to know many of these channels, TV channels, do use, Professor Rajeeva Karandikar has been into these news channels for their opinion polls, whatever you know. And we see he was associated with newspapers also. In fact, he's a specialist in stochastic calculus, and he was associated with ICICI Bank and other things. So he's one mathematician who is really into the practical world, also contributes a lot. And of course, he is a recipient of Bhatnagar Award, and he's one of the most well-known probabilist and statistician in our country. Professor Rajeeva Karandikar.
Thank you for the invitation and the nice introduction. And I've been associated with KSOM right from the inception. When KSOM started, I was actually, at that time, I was working with the industry with Crane Software. And I was a member of whatever committee it was formed to initiate KSOM as an industry nominee, so to speak. So I was there physically at the time the campus was inaugurated by the then CM. And subsequently, I have come a few times and have been there on this meeting, that committee, etc., etc. So it's been a pleasure to be with KSOM. Wonderful place. And I wish we were not in this COVID scenario and I was there live on the campus today. But we have to make do of the best what we have. So let me come to today's talk. And today's talk is based on a mathematical or statistically, the idea is extremely simple. You don't need anything more than even class 12 or class 9 mathematics to understand what is going on. But the impact is huge, as you will see in the talk. So this is about accuracy of sample-based prediction. Okay, what does it depend upon? Okay, so typically the common sense that people have, and I don't blame that, common sense is that somehow the sample size needed should be related to the population size. But the answer is surprising, as you will see. All right. So in the first 2-3 slides, I'm going to go over the math and stat ideas that are needed. Beyond that, nothing is needed. Okay. So simplest idea is about the notion of probability. And that too in a very, very simple scenario. If you have an urn with m balls, identical in all aspects except for color. Okay, everything else is the same, and k of them are orange and the rest are green. All right. Now, if the balls are mixed and without looking into the urn, if one of them is drawn, then the chance of it being orange is k by m. So assume that we are live there, and I'm at the conference hall or seminar hall with the urn in my hand, and I walk into the audience and walk to one of the students and ask them to pull out a ball. All right. So what is the probability that the ball is orange? And then it is, we model it as k by m. This is based on the premise that each ball has equal probability of being drawn. And since there are k orange balls, the required probability is k by m. This is what is taught in school. First time you are taught, etc. All right. So this is the simplest premise. Now, suppose I also tell you, I'm there with you and I tell you that m is 100, that is there are a total of 100 balls, and k is either 99 or 1, that is either 99 are orange or 99 are green. One ball is drawn after mixing without looking and its color is found to be green. Okay. Now we have to make a decision about k. Choose one of the two possibilities, k equal to 1 or k equal to 99. If k is 1, the probability of drawing green ball is 0.99. And if k is 99, then the probability of drawing a green ball is 0.01, as we saw. All right. So this is the thing. So I've actually, if I were there live, I would have done this experiment, not with urn and balls, but with the box and slips of paper. And if you search on YouTube with my name and opinion poll, you will see many talks. And in several of those, I have done this live, going to the audience and making one of them draw a slip and read it out and then asking the audience this question. So now assume that this experiment I did before you, and one ball was drawn by one of the students, and the color was found to be green. All right. Now I asked, based on this, what would be your guess? Which is the dominant color? Or 99 orange, 1 green, or 99 green, 1 orange? Okay. Often there are no answers, but if there's students, I can give a incentive that if you get it wrong, no penalty, but if you get it right, your next assignment, you get 2 days extra to submit. So now everybody wants to guess, because there is no loss, there is only a potential gain, right? So I must have done this experiment maybe nearly 100 times by now, and almost always, or rather always, the answer is whichever ball or whichever color is seen. Then the thing is that most of the balls here, 99, not 9900, but 99 balls are green. So common sense tells us that if you have seen a green ball, you guess 99 are green. If you see one orange ball, you can guess 99 are orange. Okay, go with whatever color you see. That's the common sense. And this is what is in statistics. You have there are various names for it. One is likelihood. So you compute what is the likelihood of whatever you have observed. Under one scenario, it is 0.99. Under another, it is 0.01. So you go under which there is a huge likelihood as compared to the one with less likelihood. There is a Bayesian framework, but none of this is needed. This is what common sense tells us. And whenever in life we have to make decisions under uncertainty, this is what we do. Okay. And this is all that is needed. All right. So you may say, this is so simple. Why am I making a big deal out of it? All right. So first of all, as was mentioned in the introduction, I've been associated with opinion polls for 20 years. After being what is defined as pure mathematician for at least 15 years after my PhD, my friends used to say Rajiv lives in a Hilbert space, because for a period of about 8 years, everything I wrote started with the second section started with let H be a real separable Hilbert space. So that is how abstract I was. But from there, I made a transition. I have one foot there and one in the other domain. All right. So I got involved with opinion polls. It was a lot of fun. It was also seeing that all these statistics theory that we have taught in classes, and I was taught and I have taught, actually works. So that was the other kick. Anyway, so opinion polls is one context in which these ideas are used. Of course, people can dismiss it saying it's frivolous. Why do you care? They don't care about opinion polls. All right, fine. Next is quality control in manufacturing. Now, after the Industrial Revolution, when the manufacturing started and so on and so forth, it was realized that if there are competing manufacturers, people whose products are of better quality will have a longer staying power. People have a higher sale. Now, how do you ensure that what you are making as a good quality? And there is a lot of statistics and exactly the ideas that we are talking about in this lecture coming up. What should be the appropriate sample size, so that based on that, if you say this lot is good, then it actually should be good with a high chance. All right. And it has played an important role in the industry in last 75 years in making and breaking companies. All right. In particular, the biggest example is the Japanese car industry completely taking over the US market. Okay. So quality control has played an important role in life, whether we believe in statistics and probability or not. In practice, it has played a role. All right. Then measuring socio-economic parameters. So the government in their policies need to track which way is the country going on various socio-economic parameters. And while most decisions may be driven by politics an ideology, but at least there is a huge bureaucracy, some of whom at least push for decision making based on these socio-economic observations. And these are based on nationwide survey. And I've been associated with this thing called National Sample Survey Organization, NSSO, and they do routinely surveys and have data. Likewise, now there are industry bodies who do survey, and based on their determining the state of the economy, various things are done. All right. Industry also takes policy decisions based on where should they invest based on these measurements. Government hopefully does based on these measurements. And this is again based on sample surveys, and therefore we need to understand the accuracy. Risk management. So the banks and other financial institutions, they have various requirements set up by Reserve Bank about how to manage risk, because as we saw after Demon, if one or two major banks fail, it will have a huge hit on the country. The entire economy of the country can be hit. And if a bank therefore makes risky loans, then everybody is at risk. The whole country is at risk. So banks are required to do risk management, which in turn is related in some way or the other with sample and predictions, etc. All right. Then comes this, what I call EVM VVPAT controversy. So many of you may have been glued into the election, last Lok Sabha election. Maybe some of you may not. But before the last Lok Sabha election, there was a huge controversy that electronic voting machines are faulty, and therefore by then they had introduced what is called VVPAT, stand for Voter Verifiable Paper Audit Trail. In particular, each vote is also recorded on a paper as in addition to it being recorded electronically. And the demand was that large election commission had declared that every assembly segment they will cross-verify one booth randomly chosen, and there were demands that there should be one. What does one do? Nothing doing. Starting with 10%, going up to 50%, demand that 50% things have to be validated. And with election commission ending up in Supreme Court, and with just few days before the elections were to start, there was a major hearing in Supreme Court. And I had been consultant to the election commission, and a report drawn up by a 3-member committee, which included me, was the basis of election commission's reply to Supreme Court, and was the basis for Supreme Court dismissing these petitions. So it has played a huge role. All right. And finally, even bigger than the elections and national elections, this is a global phenomena, and we have all been waiting for this. How does one determine whether a given vaccine, or in actually any drugs or any medicine, are they good? Are they doing the claimed job? So is the COVID vaccine being developed actually going to prevent people from getting COVID? And two, whether how much is the side effects? And this, of course, has to be determined based on sample. I mean, if we draw a parallel with the demand of all the opposition parties in the country in the Supreme Court of 50% sampling, if we draw it to the vaccine, it would mean that for India to accept that some vaccine is good, half the population will have to be first tested and seen that it is good. So we would need 65 crores people injected with vaccine before we can decide whether it is good or not, which is most ridiculous, right? So forgetting that demand, of course, 65 crores not possible, but obviously if we just do it one, that is not enough. So how do you decide what is the sample size, and then what is the accuracy thereof? All right. So this is, as we can see, it's an extremely, extremely important concept and principle which needs to be understood by the decision makers. So, these days with WhatsApp, you have so many jokes circulating. So there was a report that, the Pfizer vaccine or the Oxford vaccine, their claimed, whatever phrase that used, I mean, recovery rate or prevention rate, whatever, was 97%. Okay. And then along with it, they was saying that there are two news items quoted. India's whatever rate about people amongst those who got COVID, the death rate amongst them, they have got some phrase, fertility rate or whatever. Not fertility. The claim was that, on one hand, the vaccine, the recovery rate is only 97%, and without doing anything in India, the recovery rate is 98.5. So do we really need vaccine? That was the implication. Of course, this is like comparing apple and oranges, because the vaccine rate is about the whole population, and whether after getting this, whether they get COVID or not, whether it prevents them from getting COVID, whereas the rate in the other story was about those who have got COVID, how many of them are recovering or not dying. So anyway, coming back to the main theme. All right. So now it's easiest to explain in the context of opinion poll. Though, as I have told you, it has the same thing is there in many different and very important contexts. All right. So let's say consider a constituency, Lok Sabha constituency, say Chennai South, and to make matters simple, suppose there are only two candidates, A and B, and there are M voters. Suppose K out of M voters actually prefer A to B, okay, in the whole population. Out of these M voters, K prefer A to B, and P is the proportion of voters who prefer A to B. We don't know these at the moment, but let's say that this is the truth. All right. Now, the interest is in deciding whether K is bigger than M by 2 or K is less than M by 2. Let's assume that M is an odd integer, so odd number of voters. And so one of the two will occur. If there is an election and everybody votes, then one of them will win. And the question is, who will win the election? That is the interest. Okay. Now, of course, if you observe opinion of each voter, you go door to ask everyone that give you truthful answer, then we will know who is going to win. The question is, can we have a decision rule even if we observe opinion of only a few voters? So if we go and talk to, let's say total is 2 lakhs and we go and talk to 10,000 people or 20,000 people, will that give us will we be closer to the truth? Obviously, it cannot be 100% perfect. You can never be sure that this is what will be the outcome, because it would depend on which are these 20,000 people. But is there some way in ensuring that, with a high probability, like that drawing of a ball and predicting a color, with dominant color, can we come something close to that? Okay, that's what I mean by decision rule. All right, so some notation. Let's introduce variables alpha I to be 1 or 0 if Vi prefers A to B, and 0 if Vi prefers B to A. 1 or if A is preferred, 0 if B is preferred, with the ith voter. Let P be the proportion of voters out of M in the constituency who prefer, and now that we have already introduced, so that is sum of A's, and P is K by M. All right. Now, let script S denote the collection of n tuples. I1, I2, In of elements of this set 1 to M, index set 1 to M, all M tuples out of this index set, and for I1, I2, In in an index set for one tuple, we take F and G of that tuple to be just sum of A's in that tuple and proportion of ones in that tuple. Okay. So we'll call this I1, I2, In as a sample. Okay. So we are imagining that as if we choose, we have a box in which we have put in all these tuples, we pull out one tuple out of it after mixing, go and talk to these people. So then F of that and G of that will be able to observe, and this tuple is what is the sample. Okay. Now, we want to estimate this proportion for how many tuple or what proportion of tuples is the proportion in this tuple close to or away from the true proportion. Okay. So G, remember, is the proportion of ones in this tuple or in this sample, and M power N is the total number of sample. What proportion of samples is the true proportion, and the proportion in the sample differ by more than epsilon for any given positive epsilon. That is what we want to estimate. And that in turn, we will, if it is small, we'll say the scheme has good accuracy and etc. All right. So by just high school algebra, let's go back to the definition of F. You have to just sum it over all tuples, and a very simple. You can verify that the summation is n times k m power n minus 1, and the sum of squares, if you square it, it will be, each is 1 or 0. So the square term will be just itself, but they will be product terms. So you have to count product and so on. Simple high school algebra or combinatorics, whichever way you call it, both are the same here. We can get these two identities. Okay, there is no probability, no statistics involved. Very simple identities. And then using these two identities, we can see that if you take the sum of g's and divide by m power n, g is already one factor of m in the denominator to f, and then we have we'll get k by m p here, and the sum of squares we will get this. So these are simple algebra. So we get that summation of g is this p, and summation of g square and normalized is p by n minus 1 p square by n. And once again, using simple algebra, we can see that this summation, you take g minus p whole square, summation over s is p minus 1 by n. The thing is, you expand the sum of squares and simplify. Okay, you expand this by a plus b whole square by formula and then simplify. So these steps are basically, you can high school algebra, nothing more. Okay, but now already we have reached a very, very important conclusion. Okay, so if you look at this, this is the identity we have seen in the previous slide. From here, we can conclude that proportion of samples where the sample proportion and true proportion by differ more than epsilon divided by the total number is 1 by epsilon square p into 1 minus p by n. And how do you get it? Very simple. If larger than this number violates this identity, the contribution to the sum of square already will exceed p minus 1 by n. Okay. If more than these numbers differ by epsilon square, there will be so many epsilon squares coming here, multiply by this, and this identity will be violated. So the calculations that we just now did amount to something like mean and variance calculation in the elementary statistics, and then this is the Chebyshev inequality. But deliberately, I didn't want to invoke these names to convey that we are not using anything deep anywhere. It is very, very simple algebra, absolutely simple algebra. But what does this say? So remember, if we have chosen, so p into 1 minus p is at most going to be half. Epsilon is given to us. So you fix the epsilon, then we can choose a n such that this is less than 1%. Okay. 1 over 100. This is less than 0.01. Given a p and epsilon, we can choose a n such that this is less than 0.01. Now, what does that say? That says that if we choose, let's say we get n to be 5,000 or 10,000. 10,000. So if we choose a sample of size 10,000, that namely we choose randomly out of all possible groups of 10,000, we choose one of them randomly and go and talk to them. The proportion in that and the true proportion probability that they will differ is 1%, and therefore probability that they will be close within epsilon will be 99%. So if our election is not close and epsilon is small, we will see what happens. The story that just by talking to that number, we will be able to get who is winning. Important. In this estimate, capital M has dropped out. On the right hand side, there is no capital M. It is depending only on P, epsilon, and N, not on capital M. So whether M is a constituency or M is all of India, the N that will come out of this calculation will not depend on M. So the accuracy Thus, this calculation is telling you that the accuracy is depending on sample size, not on population size, not on capital M, but on small n. So by choosing large N, one can ensure that in most samples S, the sample proportion G and the true proportion P differ by a small quantity. And thus the conclusion is, if a large sample is selected at random, the probability that the sample proportion and true proportion differ at most by a small quantity is close to 1. So if I write P n hat to be this G, which is the sample proportion, then now I'm using the probability language. So probability P n hat minus P bigger than epsilon is less than equal to this. Now, so P into 1 minus P is always less than equal to half. And this for epsilon equal to 0.05, this will yield for n equal to 1000, we will get this estimate. And so we get this idea. So what this is telling us by now, that if the election is not close, so if the winning candidate is getting at least 55% votes, okay, so P is bigger than 0.55 for the winner, and for the loser it is less than 0.45. Then with high probability, our observed proportion will be either if P is bigger than 0.55, it will be over half. If P is less than 0.45, it will be less than half. And therefore, if we safely say that we take a sample of that size, 1,000, 10,000, and whoever is winner in the sample, go ahead, close your eyes and declare that person to be winner. And you will be right 99% of the time. Like my orange and green ball example. Exactly the same analogy. And whether it is Chennai South or all of India or all of Tamil Nadu or all of Kerala, the answer is the same. 10,000, you will get an idea. Okay. So what this is telling us, that the accuracy is depending on sample size, not on population size. So to estimate proportion P of voters in India that support a party XYZ, if we choose a random sample of 10,000, we would have estimated P with an error of 5%. With confidence 99% or error probability 1%. Okay. Actually, the probability estimate that I gave you was a very crude one, and all these things can be computed very much more precisely. These are computed in terms of binomial coefficients and blah, blah, blah. And so these were estimated in a much better way. Going back 300 years, de Moivre estimated these. And in fact, there is a story that he was not rich. In fact, he was thrown out of France, because he was Protestant and not Catholic. And he was living in England, very poor. And he used to make money going to casinos and advising gamblers on computing these probabilities and advising gamblers. You read a Wikipedia article on de Moivre and you will have these interesting tidbits. Okay. So by much better computation, we can actually get more precise estimates, and what eventually led to the de Moivre central limit theorem. But for n equal to 640, not 10,000, you get this probability estimate. While n equal to 4125 gives you this estimate. And to ensure that you have within 1% of the true proportion with confidence 99%, you need 65,500. So accuracy is being determined by two quantities. This is the error probability, or 1 minus this is the confidence. And this tells you within what proximity our estimate is required to be the true quantity. So accuracy is being measured by these two quantities. So is being measured by alpha and beta. The estimate is within alpha of the true value with confidence 1 minus beta, or the error that the estimate and true value differ by more than alpha is beta. Okay. So now this is the classical central, there is a bracket missed in the numerator. The central limit theorem gives that root n P n hat minus P divided by square root P into 1 minus P. The probability that this ratio lies between A and B is approximately equal to this integral below, which we call normal integral or Gaussian integral. Okay. And that is the de Moivre's theorem, going back, as I said, nearly 300 years. And these integrals people had computed approximately, and there were every statistics probability book used to have a table of this, and now every software has a built-in library to compute these integrals, a to b. There is no explicit integral available. You need only numerical integration here. Yes, different tricks of doing numerically this integral. All right. So we can then get various things. Bigger than alpha, it is beta n, where beta n is this integral, and you can compute from there the from here we can compute the required n needed to get the achieve the accuracy alpha beta. So you give me alpha beta, and we can come out with the n. All right. Now, an important point. In the discussion above, we have taken n tuples of elements and treated them as samples. So this is called simple random sampling with replacement, because when we are looking at tuples, the index can be repeated, and that's why we had m power n total tuples. Okay, that made our calculations very easy. Of course, in practice, it doesn't make sense to allow repetition. You can't go back to the same person and ask, what is your opinion about such and such issue, or who will you vote for? They'll say, hey, yesterday you came and I have answered. If you say that, no, but you appear in my sample twice, they'll consider that you are crazy. Okay. So it doesn't make sense. So in practice, you instead of all tuples, it makes sense to take all subsets of size n as samples. And this is called simple random sampling without replacement, written as SRSWOR. So you draw one and don't put it back, and the second one is drawn out of the rest. Okay. Now it can be shown that the estimate of error obtained by the with replacement is an upper bound for the error without replacement, and you can actually compute exactly probabilities and whatnot. All right. So once the sample size is negligible as compared to the population size, these probabilities are also approximately equal. So if you have an opinion poll in one constituency, only two candidates A and B once again. Suppose now the leading candidate has 52% support, losing candidate has 48% support. We have randomly chosen n equal to 2k plus 1 voters out of capital N voters. The logical decision rule is to predict candidate who gets support of k plus 1 or more voters in our sample to be the winner. Now the next page is going to give the probability that this decision rule picks the correct winner. Okay. So once again, winner has 52% support, population size is n, the column header, sample size is small n, the row header. The table gives accuracy of this rule. Winner in the sample is declared the winner. And the accuracy, as you can see, this is the small n, the size of the sample. And this is the population size. And interesting observation that the rows are nearly the same, columns differ, okay, but rows are about the same, and each row here it has become constant. Last two entries in this, it has become constant. Last three entries, as we increase, it is constant over last 5 entries. 4001, it is again same. So as population size increases, there is a marginal improvement or marginal decay, but eventually it is going to stabilize to the stable value which we are arriving at. Now, if we keep increasing, it's not going to reduce much. It's going to remain this. If we increase the population size, I forget, this is 5 million. From 5 million, we make it 1 billion. And try to write down, it will be 99.4 and 98.6. It is not going to change. Okay. So what this is saying is that if you have 4,000, we are very sure that our thing will have, decision rule will have 99% accuracy. Sample of size 4,000. Okay. Doesn't matter whether it is all of India, one constituency, more constituencies, one state, all country, wherever. You would have estimated the true the winner with high probability, 99% confidence, just like my green and orange ball that I started with. Okay. So, of course, you may ask that if you make it sound so simple, why do opinion polls go wrong, even your own? That is, I have had a fairly good track record, but of course not on the dot, and there have been some times where we have been off the mark. So that question I need to answer. Why do we go wrong also? And indeed, I've given talks on this in hundreds of times, and on one such time was a talk in Pune University, and it was a morning talk, 11 a.m., a public talk, and it happened to be on a day when the UP election, this was I think 2012 assembly elections in UP, the counting was to start, 2017, not 12, 2017. And even before my talk began, based on the partial counting trends which were available, it was clear that our prediction had gone wrong. And that occasion, I had to get up and stand and give my talk. But always, when I was talking exclusively about opinion polls, my title used to be something like power and limitation of opinion polls. If you see YouTube videos, you will see this. And you also have this Pune University video there. And I said, glad that I always have chosen power and limitation, because today is an example of the outlining the limitation of this methodology, that we can be wrong. Okay. Anyway, so, all right, now let's come to a nationwide opinion poll before Lok Sabha. Nationwide survey is just a first step in opinion poll for the object, because the objective is to predict which party, if any, would get majority of seats and the likely number of seats. Survey gives vote percentages, and we need a statistical model to convert the vote shares to predicted seats in the parliament. It's not easy. And today I'm not going to go into that. You can see my YouTube videos, which I give some more details about this. But for those who may think that, no, but why shouldn't that be true? Once we have vote percentages, shouldn't the winner, who is the largest vote percentage, also be the winner getting the maximum seats? Even that is not true. And you might recall recently we had the Trump and Biden election. But 4 years ago, a lot of talk about the Trump-Hillary election and how opinion polls went wrong and whatnot. And actually, the vote percentage of Hillary Clinton was accurately measured by most polls in US. And they had correctly predicted that it was a close election, but Hillary Clinton will get marginally more votes, 1% say roughly more votes than Trump. What happened was that while the vote estimates were correct, the transfer to votes to seats was wrong. And there it's not parliament seats, but there's something called electoral college votes. And electoral college votes, Trump got more and became the president, ruled as president, and so on. In India also, actually last 2 assembly elections in Karnataka, if my memory is right, Congress got more votes, but BJP got more seats. And it is to do with Congress having spread across the state, whereas BJP having pockets of influence and being completely absent in some. Now, overall, if they have to have the same percentage of votes state-wise, if BJP has none in some constituencies, it means they are proportionate more in the remaining, and then they win those remaining seats. So, little bit of thinking, you can see that this is easily, it can happen. It depends on how these votes are distributed, not just who has more percentage votes, but how these votes are distributed. Anyway, as I said, this is not the topic to go on in today's discussion. You can see other videos. Let me come to the EVM VVPAT controversy and the crucial role of sampling and how the importance, of course, the same kind of computations, the central limit theorem based computations would come into picture when they have to decide how many people should be tested with the vaccine before we can declare that it is effective. Okay, how much? Obviously, the smallest number that will give you the required confidence is what would be done. And determining these is very, very critical in deciding whether or not to declare a vaccine to be effective. Okay. Uh, of course, there will be lots of naysayers. There will be a lot of people who will doubt this. There are people already who are saying that no way they are going to take this vaccine and so on and so forth. So the controversies will remain, but those who have a scientific mind should at least understand. You may decide that 99% confidence is not good enough for me, but just don't dismiss that. Oh no, this is no good. So you understand the scientific rationale behind the approval process, and if you don't, either you believe that this is manipulated and what is being claimed is not correct, or you believe that this is not good enough. Either of the two, you decide you are not taking a vaccine, which is fine, but just don't go with the WhatsApp messages circulating, raising all kinds of questions. All right, so all right, so let me come to the EVM VVPAT controversy and the crucial role of sampling in it. So firstly, for those who may not have followed these stories and what is EVM, what is VVPAT, from when have they been used, what have been people said, what are the courts said, etc. All right. So brief history. Interestingly, the first usage of an electronic voting machine was in Kerala in 1982. Okay. And not all booths, but in few booths in that assembly constituency, EVMs were used. And the losing candidate went to court. And first the district court, then high court, but eventually it ended up in Supreme Court. And finally, the Supreme Court declared the use of EVM illegal or invalid, and declared that the elections in at least those booths have to be held again. And the reason was very simple, that the elections in India are governed by a law called Representation of People's Act. And Representation of People Act went on and on describing gory details about paper ballot and about the polling booth, voting booth in which you have to cast your ballot and so on and so forth. And the court simply observed that there is no provision in the law to allow EVM. So we have no choice but to declare that this is invalid. If you want to use EVMs, write down rules, bring in a law, enact it, only then use EVM. Till then, this is invalid. That's it. Full stop. 82. Okay. Then after some years gap, Election Commission went on overdrive, started doing discussion papers, inviting various suggestions how to go about it, etc., etc. And before that, they have to have a legal provision. So eventually, after 7 years, 89, Parliament approved a law, inserted a section in the Representation of People Act, which gave EVM legal status. Of course, after that, then you have to come out with detailed guidelines, rules, design the EVM, manufacture it, etc., etc. So Election Commission then engaged a public sector undertaking, ECIL, to design and develop EVMs in consultation with experts. I believe the experts were from IIT Bombay. Then later, after it also added Bharat Electronics Limited, another public sector undertaking, to go with ECIL and work out with the technical expert committee to go with the design and develop and manufacture the EVMs. Okay, it's a long year. It is a process which has gone on for years. It is not that next day suddenly decided and they are brought in. All right. So remember the Act 89, 99 Goa election, Goa Assembly election, the prototype or the type of EVMs which is now in use were used first time. Okay, some various trials held, consultations held, approved, then manufactured on a somewhat large enough scale, so that they picked Goa because this Goa is small and you did not have to manufacture a large number to start the process, so that in case there are problems found, you can revisit. So 99 Goa successful. Then by October 99 Lok Sabha election, they tried 46 Lok Sabha constituencies across the country, were chosen to use EVMs completely. Okay. And incidentally, by then I was already involved in opinion polls. 1998 is when I was involved. And so I distinctly remember, I used to be in Delhi in any case, that Election Commission had called a press conference where they were going to unveil the EVMs. They are going, unveil that they had already used it in Goa, but bring it to the national capital and announce these are the machines and these are their features, and circulated pamphlets describing the features, and I had an open house to invite questions. And since I was already working with the media, I also went to that conference. And my first impression when I saw that, the design, was that, oh, come on. We are nearly in the year 2000 and we are making a EVM which is very primitive, because there was no networking. They showed that after the voting is over, counting day, you press a button and it displays who got how many votes, which you write down by hand on a piece of paper, and then get sign of all the agents that, okay, this is the counting outcome for each booth. I thought, why is it? I mean, the simplest. In that day, Bluetooth and Wi-Fi were not still that common by 99. They're there, but not common. So at least networking, Ethernet. Why can't there be an Ethernet jack where you can pull out the data and get, instead of rewriting? That was my thought. But what I thought was the weakness is actually the strength, as we will see. Okay. So it just displays the votes for each candidates. And you write a piece of paper, enter it in some database, and then you add them up. Okay. No Wi-Fi, no Bluetooth, no networking of any kind. But this is the this is also the strength, because anybody who is familiar with electronics or with computers beyond just usage will tell that once there is a Wi-Fi, once there is a Bluetooth, once there is a networking, there is an operating system. And then operating systems are vulnerable. We have to constantly keep getting alerts to upgrade our system because some security patch. That means we don't have perfect OS. Okay. These are vulnerable. Somebody can get into your machine and tinker with it. Okay. Once you have networking. At least the possibility cannot be denied. It may not be easy, but possibility cannot be denied. So remember this, but so 2004, the entire election of the whole country was held using EVMs. While there were mild murmurs that, EVMs have malfunctioned, etc., but people could not create much fuss because the ruling dispensation lost out. So they can't say that we maneuvered it and we made it so that we lost. Obviously, that is not credible. So not much noise was made because the government in power lost. Now, 2009 was the year the government in power was UPA, led by Congress, and they won. And after that, there were lots of allegations that they won only because of EVMs have been tampered. Vague allegations, no concrete allegation. Vague allegations by opposition parties then, which included BJP, and several court cases were filed questioning the EVMs. Of course, the ruling party supported that and saying that everything is fine, we didn't tamper. They cannot be tampered, but the opposition opposed and said they can be tampered, went to court. In particular, most petitions were dismissed, but Mr. Subramaniam Swamy, he had gone to court making lots of allegations, but one of his legal grounds found favor with the court, which was that even after the amendment and bringing in EVMs, there was one clause which still remained, which said that in case of election petition filed by a candidate, the court can still order recount. Okay. And he said that now that is out of question, because what is recount? You can press a button. The button has been pressed once and you have displays. So EVM negates the possibility of a recount and therefore it is invalid. That was his petition. And court kind of found favor. Fortunately, they didn't declare the entire previous elections to be invalid, and that would have thrown country in chaos. But in the hearings, they kept on. Election Commission had been also served notice. The central government had been served notice, and it came out that okay, they will try to bring in some way that there can be a recount. And similar things had been happening in Europe too. Of course, their EVMs are very different, and this concept of this VVPAT has that origin. And finally, the EC gave an assurance that they will bring in these VVPATs, and that can be used to recount if need arises. And based on that, this assurance, the Supreme Court did not pass any judgment in the Subramaniam Swamy case, but they said that from now on it should be introduced. Of course, Election Commission said that we need budgetary allocation. I mean, it required, I may be wrong, but it required something like 4,000 crores to manufacture the enough number of VVPATs to have Lok Sabha election conducted using that. We needed 16 lakh EVMs. Okay, but so this assurance was 2013. By 2014 election, they could not have had manufactured this large number. So it came into being. It was 2019, which was the Lok Sabha election, where it was going to be used. 2014, VVPATs were not there. 2019, it was there. In between some assembly elections, they started using VVPATs, and the experience was good. Now, we know that EC had promised VVPAT, but there was no demand that before the election petition, there should be paper trail ballot counting should be done. Okay, it was only to be done when the election courts order a recount. Election Commission thought that since there had been so many questions about EVMs, to increase public confidence, they will randomly choose one booth in each assembly segment and actually count both and show that everything is matching. Okay, so that is what Election Commission thought and announced. And this was what was done in MP, Rajasthan, Chhattisgarh elections in 2018, few months before Lok Sabha election 2019. Already before these Vidhan Sabha elections, already there were petitions in court demanding, started by demand of 10% count, 20% count, 30% count. To answer that, the Election Commission appointed a committee which included me, and I had my colleague Abhay Bhatt from ISI, and also Officer Omkar Prasad Ghosh from the Central Office, Government of India. Three of us, we had a few meetings, we discussed and understood the whole process. And based on that, by the time we started discussions, more petitions were filed, and the number of VVPATs that were in demand to be counted went up to 50%. And this included all the opposition parties other than those in NDA, and was backed by at least 75 retired IAS officers, retired at a very senior positions at the level of secretary. Most of them would have been in decision-making capacity in some way or the other, in approval of money for the VVPATs, or in Election Commission for this, or in consultations. But by then, they are all retired, and they were also demanding 50%. And as I said, if we translate that to the vaccine, it would mean 65 crore tests have to be done in India before government declares something to be good, a vaccine to be good. Anyway, so the technical expert committee with whom also we met was confident about the design, and they told us why, and the ECI was also confident. And this is where not having the, so essentially this is not a computer. The EVM is not a computer. There is a computer chip, but it's not a computer. There is no operating system, and there is no upgrade available. Once everything is printed circuit board, it is printed on the board, you cannot tamper with it. You try to tamper with it, it will all break. And the way it is distributed across the country, and it is in two parts, and anyway, there are a whole lot of details. And based on that, we were also very happy that actually, if there is any tampering happen, it will be detected by them before the voting starts. Okay. Another important aspect is the order of candidates on the EVM is the same as it had been on the paper ballot. First, the group of national parties, then group of candidates from state parties, then the rest. And within each group, alphabetical by name. Important thing is that centrally, you do not know in what order the candidates will appear before you send them to the states and before they are sent to the districts. So What it means is that even if somehow there was possible to tamper the EVM, centrally one person or one entity cannot do it in Delhi, because you don't even know whether you want to transfer votes of 3 to 1 or 1 to 2 or what, because you don't know in whose favor you would like to rig, even if it was feasible. So it is, unless a huge army of people was involved, it is not possible to tamper. Okay. And in any case, if EVMs can be tampered, the old system could also be tampered. So after one of my talk, the headline given in newspaper was that EVMs safer than old paper ballots, says an expert. So that is the actual thing. Okay. All right. So now comes the statistics. So our assumption that if someone is able to come up with a way of tampering EVMs, it will be on such a scale so as to tilt significantly the national outcome. And if you just change it in 1 or 2 constituencies, the national outcome will not change. So our contention was that if it can be established that less than 2% of EVMs have some fault. Remember, these are mechanical systems. They can have a manufacturing fault. Also, the VVPAT is a mechanical system. EVMs, at least after the mechanical thing inside, it is electronic. But the printing mechanism is mechanical, and some may fail to print. In some places, polling booth officers may fail to make the proper adjustment of the printing unit, etc., etc. So if it can be shown that less than 2% have some fault, manufacturing or procedural lapse or tampering, we can still conclude that there is no systematic tampering of EVMs across the country. And based on these computations which we had seen earlier, our determination was that we made a very high confidence level, and you may wonder why this strange number. It is that probability of observing a deviation of more than 4 sigma sampling from a normal population. More than 3 sigma is unlikely, more than 4 sigma is extremely unlikely, and that is why this choice. And the computation said that n equal to 479. If you do 479 matchings of VVPAT and EVM counts, then we can be assured that high confidence level, that less than 2%, and therefore no systematic tampering across the country. All right. So in all, there were 10,38,000 booths across the country, and 479 is the correct choice. And one can do an exact calculation with sampling without replacement, because some people challenge that, you are making approximations, you are doing this, you are doing that. So one can write a simple Python code to come out with exact calculation of these probabilities and show that n equal to 479 is also correct for the given scenario. And this is, of course, a negligible proportion. People believe that at least answer should be in terms of percent, 1%, 2%, 5%, 10%. They say, okay, we agree 50% is huge, but at least 5% kar do, 1% kar do, etc. All right. Now, the Election Commission, while agreeing with our approach, an analysis had a different twist. They wanted to stick to their policy of 1 booth in each constituency segment. While this meant more booths, but they were not choosing randomly across the country. That was randomly in each constituency. And they wanted us to evaluate if this policy is good enough for our purpose. And we said yes. We said that if at least 1% defective EVMs were spread across the constituencies in whatever possible way, the chances that EC's sampling scheme will fail to detect a single detective is still less than this, so very good. So this is what was our report, which was presented to the Supreme Court. And in the process, Supreme Court said, final hearing was just a few days before the poll, and Supreme Court accepted this report. They said, all right, everything is fine, but if you are doing 1, why not do 5? Just 5. And so Election Commission accepted that as well. So that is what was finally done. And we showed that if EC follows the Supreme Court suggestion, then they can actually be confident that the proportion of defectives is less than 0.5%, and the confidence can be 99.9999999% confidence. Okay. Even these calculations, they are very conservative, because exact calculations cannot be done. It's kind of an integer optimization issue. And if people are interested, students are interested, they can later get from me exactly what is the optimization thing which needs to be done to get the exact answer. But even the crude bounds would tell me this confidence. I believe that with this confidence we can say that the proportion defective is less than 0.1%, but I can't show it. Okay. So to conclude, this thing about the accuracy depending on sample size and not on sampling fraction, that is proportion or percent of sample as a percent of the population, that is totally irrelevant. And common people believe so. We can't blame common sense, but the effectively I have tried to show, and I hope you would see this flow of argument as to why the sample size and not proportion is what is important. So I've run out my time. There's no time left for questions, but I guess since there is no talk, I can answer questions. No problem. No talk following this.
Yeah. Thank you so much, Mr. Rajeeva. It was a wonderful talk and really cleared, at least I had also a similar doubt. And so this calculation really cleared my doubt, and it is really very, very interesting. And I'm sure that the other participants from all over must have enjoyed this talk from a really professional person who has used, pure mathematics in the practical world. So now inside the seminar room, is there any question? Yeah, Akhil.
Sir, you in the first portion you told like there is a chance of defective machine is around 2%.
Huh.
So it may influence 2% of the total consistency, or
okay. Okay, so it depends on, so the whole thing is, scenario is like this. Let's say there is one group which has figured out how to tamper. Okay. Now, would they be happy to just do it in a few constituencies or do it nationwide is the one question. If they do it in few constituencies with 2% thing, maybe they can influence 10 constituencies, they can tilt. Let me tell you that even identifying where you are losing and actually you need to tamper itself is a big problem. Okay, so we can be safe that not more than 10 outcomes will be affected. Okay,
but 10 is a quite big number. It's like when there are many years in Indian election, the winning margin is less than 10.
No, not 10 seats. No. See, the point is the following. Okay, that was with 479. Now look at this final thing. Okay, if the proportion defective is less than 0.5%, okay, then maybe 5 seats, maybe 3 seats nationwide. Okay. All right. And the thing starts with that these things should have been seen before you invested total of 10,000 crores in this whole exercise. Right? If after doing this nationwide you throw it out, then what happened to all the people who made these decisions across the years and invested so much money? And let me tell you that the tampering in this is very difficult. In the old thing, all you needed to do was to bribe a few people and go and tamper. There were stories about, stuffing of ballots, this and that. So it is not that the previous one was perfect and now we have brought in something which there is a possibility of tampering. No, quite the contrary. Okay. So the whole business of going into EVM was to avoid the malpractices which were rampant across the country. I hope I have answered your question that this is actually better than the old system. It is not perfect. Okay. It's not perfect.
Yeah.
Any other from the yes?
So when we are sampling, for example, for an opinion poll, and you're doing it randomly.
Yeah.
What about trying to diversify your sample according to the characteristics in the whole population? So, for example, in the VVPAT also, the EC wanted to do it per constituency.
Yeah.
So, which one do you expect to be more accurate, like the random one, or if we were to diversify based on the characteristics of the whole population?
Okay, so these two are different questions. Okay, and the reason, different contexts. In the EC thing, I would think that random is better because you are revealing your strategy to the adversary. If somebody has a tampering mechanism, okay, then they know that in each constituency you are doing only one. Okay, so they can actually tamper in a suitable. So if 4079 one per constituency versus 4079 nationwide, I will go with 4079 nationwide for the VVPAT part. Okay, because this one is revealing to the adversary a certain thing. But in the opinion poll, there is no adversary. You are only measuring existing thing, and their diversification as much as you can bring in is important. But we don't do it randomly. But for example, we know that different states have different characteristics. So we diversify across states, but you can't really diversify across other characteristics because all you have is a voters list which lists age and gender. You don't have caste, religion, economic status, etc., on the voters list. So if you are going to randomize using the voters list, there is a limitation to what diversification you can do. Okay. Others do what they call quota sampling. They only diversify, but within a diversified group, they pick anyone. So they do not do randomized. And I believe that our system is far better than the so-called quota sample. And we can have a debate discussion later. You can see my other videos, and you have still questions, you can write to me. I can give you answers. Okay.
Any further question here in the seminar room? Okay, so we move into the Zoom participants through Zoom. So if there is any question from anybody who is through via Zoom. Doesn't seem like. So is there any Srijit in YouTube chat?
Professor Rajiva, I have sent you the questions in your chat box in Zoom. Did you find it, sir?
Okay, let me see. So I should stop sharing, I guess, first. Yeah. Okay. No, theory doesn't assume that a stable, the question is, since the theory assumes a stable underlying distribution, has anyone tried using repeated sampling to estimate how volatile public opinion is? Okay. So there is no assumption of a stable distribution. But if you mean stable across time, then that assumption is not there. And the assumption is, even if someone makes it, it is invalid. Okay. So I don't know the question is stable over time or what, but we have ourselves had an occasion to do repeated sampling, same population, same target audience in 99, and we had seen that 30% had changed their mind over an average gap of about 15 days before the election. Okay. And therefore, I have said in my talks, when I give election talk, that any opinion poll conducted pre-election based on that prediction, it is prediction for what is the picture then. It's not astrology to predict what will happen on the election day. So prediction power of a pre-election opinion poll is very poor, because specifically for this reason, because public opinion is very volatile, especially close to an election. Benford law, etc., I don't believe in it all. I don't even want to talk about that. And students t-test when samples are small. Now, these are technical questions. They are according to law. It's not law of large numbers, but it is then based on probability distribution of the t-distribution. And if the underlying assumptions are true, then the t-based accuracy is also correct. Okay. So then the whole thing is, whatever assumptions have gone in to the conclusion, they need to that has to be verified that those assumptions are holding. Those assumptions hold, then the small sample thing is also valid, not an issue. Okay. Are there any other questions?
There are no more questions from the YouTube channel, sir. Thank you.
Okay, so let me just conclude by one comment that the calculations using simple algebra, which I shared at the beginning, first few slides, were actually worked out or written out. This style was written out by me in the very first talk I gave, and that was a colloquium talk at TIFR Mumbai. My sole talk at TIFR Mumbai was on such a theme. Okay, number one. Number two, interestingly, one of my colleagues in ISI Delhi for years, Professor Rajendra Bhatia, After I had left Delhi, though we were colleagues together for 15 years, after I had left, in one of my visits, he asked me a question on matrices and about mean, not in the usual sense, but matrix mean when you think of it as a multiplicative notion, which is non-commutative. And he had a conjecture, and the way to prove that conjecture, we worked out using these calculations, precisely these calculations in a very complex Riemannian matrix, blah, blah, blah. And that paper became an interesting paper. The first ever I wrote with a colleague with whom I was there for years when didn't do. So the simple calculations sometimes can be taken to a more abstract and more complex scenario and can yield interesting insights. So let me conclude.
Yeah. So I have just a very small query. So the pre-poll thing might go wrong because within 15, 16 days, people may change their opinions.
Yes.
Polls. Also sometimes go wrong. It's not about just the seats. What are the probable reasons? What could be the probable reason?
Okay. So 2-3 things there. In exit poll, one thing is about the methodology of choosing a sample. Okay. So I have worked extensively with this entity called CSDS, Center for Studies in Developing Society, CSDS, which is a public institution in Delhi. Apart from that, all other people who do polls, okay, they do it in a way that you randomly, suitably choose the booths where you are going to do the catch the respondents. But beyond that, you can't do randomization. If I or someone stands outside a booth with a list of people and everybody who is coming out, you say, sir or ma'am, is your name on this list? In which case I want to ask you. Nobody will stop. So then we have to necessarily give freedom to the enumerator to pick whom he or she wants to talk. And that introduces biases. We had tried to do this a few times and we stopped doing it because the sample was just not representative on the socio-economic parameters. There are techniques of so-called adjustments, but that is one reason. Typically, the males would be more than women. More educated will be more than, and it's enumerator standing. He sees a lady dressed in a very village clothes, looks illiterate. He says that if he stops her, it will take forever to get answers. Okay, things like that. So that is one. With CSDS, we have tried to do day after poll. So we go door to door, but day after the polling is done and try to get answers. But of course, the media wants the answers as soon as the polling closes. Okay, so but even that, things can go wrong because ultimately we can only lay down guidelines. Ultimately, it depends on the supervisors and the enumerators who go to the ground. Okay, so we try to do tests and checks, and generally we have been good. But even with CSDS poll, we have been wrong. Even with vote percentages, the UP 2017 that I talked about. Okay. Yeah.
Thank you so much, sir. It was really very, very interesting talk, and we all are grateful to you, sir. Thank you so much. And we'll